Welcome back to the deep dive. Today we're tackling domain-driven design, or DDD for short. You've sent over some really interesting excerpts from Eric Evans's book on the subject.
Yeah,
It's
it's a classic.
considered by many to be the definitive guide.
For sure, Evans really lays the foundation for how to build software that reflects the real-world complexity that's supposed to handle.
Now, I'll admit, the first time I heard the term domain-driven design, I picture some seriously technical stuff. But reading through these excerpts, it's clear that DDD is about something much more fundamental. Understanding the domain, the specific area of knowledge that the software is supposed to serve.
Exactly. It's like before you even think about writing a line of code, you need to truly understand the problem you're trying to solve. Like if you're building software for a bank, you need to grasp the intricacies of financial transactions. If it's for a shipping company, you need to know the ins and outs of logistics and supply chains.
So instead of jumping straight into technical solutions, DDD is about putting that domain knowledge front and center.
Absolutely. And what's fascinating is how often traditional software development gets this wrong. There's this tendency to prioritize, technical frameworks over deeply understanding the domain.
It's like that story Evans tells about the film editor, right?
Yeah.
The one who is so focused on technical perfection that he edited out all the pauses in a comedic scene,
Yeah,
completely missing the point of the humor.
precisely. It's a great analogy for what can happen when developers get so caught up in the technical details that they lose sight of the core purpose of the software. They end up building technically impressive systems, but they miss the mark because they don't truly solve the domain problem.
Okay, so DDD is about avoiding that trap. But how does it actually work in practice?
Yeah.
How do you go from understanding a domain to building effective software?
One of the key tools in DDD is the concept of models, and these aren't just technical diagrams. They're a way to capture the essence of the domain knowledge in a form that both domain experts and developers can understand.
So it's like creating a shared blueprint
Yeah,
that bridges the gap between the technical and the non-technical.
that's a great way to put it. The model becomes a common language, a way to communicate, explore, and test ideas.
But how do you actually build these models? It sounds like a pretty complex process.
It is, and it's certainly not a one-shot deal. DDD emphasizes knowledge crunching, an iterative process of discussions, refinements, and experiments. You might start with a basic model and then refine it as you gain deeper insights into the domain.
So it's a lot more than just sitting down and drawing some diagrams. It's about ongoing collaboration and learning.
Right, and the goal isn't to capture every minute detail of the domain. It's about identifying the core concepts and relationships that are essential for the software.
Could you give me a real-world example of how this might work?
Sure. Imagine you're building software to simulate signal propagation in a printed circuit board.
PCB design. That's a pretty specialized area.
Exactly. And to build an effective simulation, the developers would need to work closely with PCB engineers to build a model that captures the key concepts of signal flow, components, and connections.
So the model would be like a simplified representation of a real PCB, highlighting the aspects that are relevant to the simulation.
Exactly. And this shared model would allow even a software specialist, who's not a PCB expert, to quickly grasp the core concepts of the software and communicate effectively with the engineers.
Okay, so we have this shared model that everyone understands, but how does that translate into actually building the software? It seems like there's still a gap between this conceptual model and lines of code.
Yeah, that's where the magic of ubiquitous language comes in. This is one of the most powerful ideas in DDD.
Ubiquitous language. It sounds pretty profound.
It is. It's about creating a shared vocabulary that emerges from the model itself. Instead of using technical jargon or vague business terms, everyone, developers and domain experts alike, uses the precise language defined in the model.
So you're not just building a shared understanding. You're building a shared way of talking about the domain.
Precisely. And this has a huge impact on the development process. Imagine a developer asking a user about a customer record. That can mean a lot of different things. But if they use a term from the model that has a specific agreed-upon meaning, the communication becomes much clearer and more efficient.
That makes sense. It's like instead of speaking different dialects, everyone is speaking the same language,
Yeah.
reducing the potential for misunderstandings and errors.
Exactly. And Evans provides a great example in the book, contrasting two dialogues between a developer and a user. In one, they're talking past each other because they lack a shared language. In the other, they're using the model's vocabulary, leading to a much clearer and more productive conversation.
So it's about going beyond just a shared understanding
Mm.
to create a shared way of expressing that understanding. But what happens when you're dealing with a really large and complex project? Multiple teams, different parts of the system. How do you manage all that complexity with DDD?
That's where DDD's concept of strategic design comes in.
Strategic design.
It's all about breaking down those large, complex projects into more manageable pieces.
So instead of trying to build one giant monolithic model,
Mm.
you divide and conquer.
It's more nuanced than just dividing. DDD introduces this idea of bounded contexts, which you can think of as separate areas of the system, each with its own distinct model.
Kind of like countries on a map,
Hmm.
each with its own language and customs, but still interconnected.
That's a great analogy. And just as a map helps you navigate between countries, DDD uses something called a context map to visually represent the relationships between these different bounded contexts.
I'm starting to see how this helps manage complexity. You're essentially creating a modular system where different parts can evolve independently.
Exactly. But it's not just about separation. It's also about understanding how these contexts interact with each other. The context map helps you define those interactions, ensuring that the different parts of the system work together harmoniously.
So it's like setting clear boundaries and communication protocols between different teams or departments.
Precisely. And this is especially important in large organizations where you might have teams working on different aspects of the system. Strategic design helps ensure that everyone is on the same page and that the different parts of the system integrate seamlessly.
This all makes a lot of sense.
Yeah.
But I'm curious, how do you decide where to draw those boundaries? How do you know what constitutes a bounded context?
That's a great question. And it's where the domain knowledge we talked about earlier becomes crucial. You need to carefully analyze the domain and identify areas of distinct functionality or expertise.
So you're looking for natural clusters of concepts and relationships within the domain.
Exactly. And often these clusters will align with different business units or teams within the organization. For example, in an e-commerce system, you might have separate bounded contexts for order management, product catalog, and customer relationship management.
So you're essentially mirroring the structure of the business in the structure of the software.
That's a good way to think about it. But strategic design goes beyond just dividing the system into bounded contexts. It's also about identifying the core domain, the heart of the system where the most value lies.
So this is the part of the system that really sets your business apart, the area where you need to invest the most effort and expertise.
Exactly. And DDD provides techniques like distillation to help you identify and prioritize the core domain. It's about focusing your energy where it matters most.
Okay, so we've got our bounded context. We've identified our core domain. How do we actually translate all this strategic thinking into concrete code? How do we express these carefully crafted models in the software itself?
That's where tactical design comes in.
Tactical design.
DDD offers a set of design patterns that help you translate the domain model into tangible code structures.
So are we talking about things like algorithms or data structures?
Not quite. These patterns are more about how you structure your classes and objects to reflect the relationships and behaviors you've defined in your domain model.
Can you give me an example? How would one of these patterns work in practice?
Let's go back to that shipping company example we mentioned earlier. Remember, they had a business rule about overbooking cargo to compensate for cancellations?
Right. That was a tricky one because it wasn't tied to any specific object, like a cargo container or a ship.
Exactly. It was a policy that governed the overall operation. In DDD, you could use a pattern called strategy to represent this kind of policy.
So instead of embedding the overbooking logic directly into the objects it affects, you'd create a separate overbooking policy object.
Precisely. This strategy object would encapsulate the logic for determining how much cargo can be booked on a voyage, keeping it separate from the other parts of the system.
Okay, I'm starting to see how this works. You're essentially creating a modular component that can be plugged in and modified independently.
Exactly. And this makes the system much more flexible and adaptable to change. You can easily modify the overbooking policy without affecting the rest of the code.
That's a great example. Are there other patterns like this that are commonly used in DDD?
Absolutely. DDD provides a whole toolbox of tactical patterns. There are aggregates, which define clusters of related objects that are treated as a single unit, factories, which encapsulate complex object creation logic, and repositories, which provide an abstraction layer for accessing persistent data.
It sounds like each of these patterns addresses a specific challenge in translating the domain model into code.
That's right. And the goal is to create code that closely mirrors the structure and logic of the domain model. making the software easier to understand, maintain, and evolve.
So it's not just about making the software work. It's about making it work in a way that reflects the domain's inherent complexity.
Precisely. But it goes beyond just mirroring the domain. DDD also emphasizes the importance of making the code supple, which means easy to understand, .modify, and work with.
Supple code. I like the sound of that. But what makes code supple? What are some of the techniques used to achieve this?
One key technique is the use of intention-revealing interfaces.
Intention-revealing interfaces.
This is about naming your classes and methods in a way that clearly communicates their purpose, without revealing the underlying implementation details.
So it's like choosing your words carefully, so that anyone reading the code can quickly understand what it's doing.
Exactly. The name of a method should tell you what it does, not how it does it. This makes the code much easier to read and reason about.
Could you give me a concrete example of this?
Sure. Remember that paint mixing program Evans mentions in the book? Initially, the code was very focused on the mechanics of color mixing, with methods like mix red and blue.
So the method name was very literal, describing the specific action being performed.
Right. But after applying the principle of intention-revealing interfaces, they refactored the code to use a more expressive method name, like create purple.
Ah, I see. Now, the method name clearly conveys the intent to create the color purple, without getting bogged down in the details of how that's achieved.
Exactly. And this small change makes a big difference in terms of code readability and maintainability. It's like replacing a cryptic instruction manual with clear, concise directions.
So it's about making the code more human-friendly, more like a conversation than a technical specification.
Precisely. And DDD goes further by advocating for side effect-free functions and assertions to make the code's behavior more predictable and easier to test. These techniques help ensure that the code does what it's supposed to do, and nothing more.
It sounds like DDD is really about creating a system that's not only deeply connected to the domain, but also a joy to work with.
That's the goal, but I'll admit, implementing DDD can be challenging. It requires effort, skill, and a shut-in mindset.
I can imagine. But what are the rewards? What are some of the benefits you've seen from applying these principles?
Well, first and foremost, DDD leads to improved communication and collaboration between developers and domain experts. This shared understanding results in software that better meets the needs of the business.
It's like bridging that gap we talked about earlier, ensuring that everyone is speaking the same language and working towards the same goal.
Exactly. And this leads to a whole host of other benefits. Reduced errors, faster development cycles, and more adaptable software that can evolve with the changing needs of the business.
It sounds like a win-win situation. But I'm curious, are there any real-world examples of companies successfully implementing DDD?
Absolutely. Evans actually shares some compelling anecdotes in the book. He talks about a shipping project that achieved partial success, but faced challenges in fully embracing a DDD culture. Then there's the story of Avant, a software company that thrived on DDD principles. Even during tough economic times, they were able to build a system that was so adaptable that it caught the attention of a major retailer, ultimately saving the company.
Those stories really bring these concepts to life. It's not just theory. It's about building better software that solves real problems and delivers tangible value.
You hit the nail on the head. And the beauty of DDD is that it's not a rigid set of rules. It's a collection of principles and practices that can be adapted to fit the needs of any project.
So it's like having a toolkit that you can draw from to create software that's both powerful and elegant. It really is fascinating to see how these principles can be applied in different contexts. So after going through all these excerpts and insights, what stands out to you as the most crucial aspect of DDD?
If I had to pick one thing, it would be the unwavering focus on understanding the domain. That deep understanding is the foundation for everything else. The models, the language, the design decisions. It's like building a house. If you don't have a solid foundation, the whole structure is at risk.
That makes sense. You can have all the fancy tools and techniques in the world, but without a deep grasp of the domain you're building for, you're likely to miss the mark.
Exactly. And it's not just about understanding the what of the domain. It's also about the why. Why are things done a certain way? What are the underlying business goals and constraints? These insights are crucial for building software that truly solves the problem at hand.
And the book really emphasizes the role of developers in this process.
Right.
The idea of hands-on modelers, where developers are actively involved in understanding and shaping the domain model.
Absolutely. Developers shouldn't just be code monkeys blindly implementing specifications. They need to understand the domain deeply enough to make informed design decisions. and contribute to the evolution of the model itself.
So it's a much more collaborative and iterative process than traditional software development, where you might have a separate team of analysts gathering requirements and handing them off to developers to implement.
Exactly. And this close collaboration between developers and domain experts is key to ensuring that the software truly reflects the complexities and nuances of the domain.
Now, speaking of reflecting the domain, the book also talks about the importance of layered architecture in DDD. Can you explain what that is and how it fits into the overall picture?
Of course. Layered architecture is about separating different concerns of the system, like the user interface, the application logic, and the domain logic. This separation helps keep the domain logic pure and focused, free from the distractions of technical infrastructure or user interface complexities.
So it's like building a house with distinct layers: the foundation, the framing, the walls, and the roof. Each layer has its own purpose, and they all work together to create a cohesive structure.
Exactly. And this layered approach makes the software much easier to understand, maintain, and evolve. You can modify one layer without affecting the others, which is crucial for managing complex systems over time.
This makes a lot of sense, but I'm curious, are there ever times when you might want to deviate from this strict separation of layers?
There are certainly situations where a smart UI approach might be appropriate, where you embed some business logic directly in the user interface, but this is typically more suitable for simpler applications,
Okay.
where the domain logic is less complex.
So it's about choosing the right tool for the job. Sometimes a simpler approach is sufficient. But for more complex systems, the layered architecture provides a more robust and scalable solution.
Precisely. And regardless of the specific architectural approach, the key takeaway is that DDD is about building software that is deeply rooted in a rich understanding of the domain. It's about creating a system that not only solves the problem at hand, but does so in a way that is expressive, adaptable, and maintainable over time.
It sounds like a journey of discovery, uncovering the hidden gems within the domain
Yep.
and translating them into elegant and effective software.
That's a great way to put it. And I think the real beauty of DDD is that it's not a one-size-fits-all solution. It's a set of principles and practices that can be adapted and tailored to fit the specific needs of each project and each domain.
So it's not just about following a recipe. It's about developing a deep understanding of the domain and using that understanding to guide your design decisions. What do you think that for someone listening who's maybe new to DDD, what would you say is the most important thing to keep in mind as they start to explore these ideas further?
I would say, don't get bogged down in the technical details right away. Start by focusing on the domain itself. Talk to the domain experts, learn their language, understand their challenges, and then let that understanding guide your exploration of the DDD toolkit.
That's great advice. It's like that saying, begin with the end in mind. But in this case, begin with the domain in mind. And remember, DDD is a journey, not a destination. There's always more to learn and explore. So keep that spirit of curiosity alive and see what hidden gems you might uncover in your own domain. And that wraps up our deep dive into the world of domain-driven design. Thanks for joining us.